All right, this is just working through the article in Khan Academy, so I'm just going to move through this. So you have a video of it, but you could also just look through this yourself if you want to spend more time with it. What is the Pythagorean identity? Hopefully this rolls right off the tongue now because we've been talking about this whole section. It is sine squared theta plus cosine squared theta is equal to 1. This identity is true for all real values of theta. Okay, so theta is that input, and it's any real values of an angle. That's just saying we don't have any complex numbers here. It is the result of applying the Pythagorean theorem on the right triangle that is formed on the unit circle for each theta. So on the right triangle, oh, smush it in there. Right triangle. All right, so here's our right triangle. We've got this degree of theta in here. We've made a right triangle with the x-axis here. You always go back to the x-axis. And this distance is always 1 because it's a unit circle. This is the radius. Here is our cosine of theta, adjacent over the hypotenuse, and our sine of theta, opposite over hypotenuse. So there's that one. Let's move on to the next part here. Whoa, sorry, I didn't mean to zoom out just there. Okay. What problems can I solve using the Pythagorean identity? So like any identity, the Pythagorean identity can be used for rewriting trigonometric expressions. Well, you can just write trig expressions if you want. There we go. In equivalent or more useful forms. So I'm just going to put more useful forms. The Pythagorean theorem also allows us to convert between the sine and the cosine values. Of an angle without knowing the angle itself. Consider the example where we have an angle theta in quadrant 4. For which the sine is, let's see, sine of theta is negative 24 divided by 25. We can use the Pythagorean identity to, and the sine of theta to find cosine of theta. So step 1, let's start with our identity. That is sine squared theta plus cosine squared theta equals 1. All right, so now we substitute in sine squared theta. So sine of theta is negative 24 over 25, and it's squared, plus cosine squared theta equals 1. All right, then we can subtract this square of negative 24 over 25. So that would look like this. Cosine squared theta is equal to 1 minus negative 24 over 25 squared. And when we solve that, we can square this. We can write this as 25 over, actually it'd be 5 over 5 because the square root of the, oh wait, no, squaring, sorry. So square this, make this a fraction so we have a common denominator. And then we would have cosine squared theta is equal to 49 over 625. All right, so then we would take the square root of both sides here. And so then cosine of theta, now that we've undone that squaring, would be plus or minus 7 over 25. Okay, because we're taking a square root. But the sine of cosine theta in the determined quadrant, which is quadrant 4, okay, we need to use. So if we're in quadrant 4, the cosine value must be positive. Okay, and I'm going to draw a little picture to show you how I know this. We're in quadrant 4 over here. Our x is positive. If we were going to have like some triangle out here that we're talking about, okay, this distance is positive, down is negative. So this is cosine, this is sine. This is where our sine was negative. Okay, our cosine is positive because we're in this 4th quadrant. Okay, so in conclusion, the cosine of theta has to be positive 7 over 25. There you go. All right, so then the next little bit here is just going to be a problem set. You have 2 problems in the article if you want to go try those out. And so if you feel like you need to, go ahead and go practice these on Khan Academy. And that's it for 7.3.